Hello everybody. In this video we'll be looking at how you can optimize your parameters for your RAG model to achieve a very high retrieval score, which in turn will boost your overall RAG performance when it comes to generation as well. So what are some of the parameters that you have to look out for when it comes to tuning? There are two very basic parameters that have a direct impact on your retrieval score, that is your top k vectors that you retrieve and your chunk size. So essentially these are the main ones that you might have to tune out, but there's also a lot more parameters that we'll be going through in this video, and we'll be doing all of this with the help of something called Mlflow. So Mlflow is a fantastic tool that lets you track out all of your parameters, metrics, your artifacts, and it keeps a version and track of all of these, which makes it very easy when you're running a lot of experiments on the fly. So now it's time to have a look at the dashboard, and we'll also have a look at how you can create the dashboard, and we'll write them out step by step. So this is how the Mlflow dashboard would look like, and I had a couple of runs that I previously run, and let's just go through few details, right? So this is the general table part, and if you go to the chart you can see a comparison of all the different runs that you had. And in my case I was tracking hit rate and MRR, and you can see that for the carrying hawk experiment I'm having my highest hit rate. Other than that, you can also go to each of your individual experiments and you can see things like more fine-tuned details, like how long it took, your chunk size, so your chunk questions, your chunk size, what embedding model that I'd used, what was the model name, my top k, and your metrics. So and yeah, here you go, you also have a nice little model metrics that that comes up separately on a different tab as well. So now let's try and code this up, and let's see how this can be implemented using Llamaindex. So let me just quickly clear out anything that I previously run, and I actually have my Python environment already enabled for the project that we're gonna run. The directory is fairly simple, you can ignore most of it. The only one you have to pay attention is I have a data folder where my .txt file is stored. You can ignore ML runs, these are the previous ML runs that I run, so we'll just let it sit there. And I have a model directory where I have my gguf model sitting in there, and a normal get ignore file, and this toml is mainly for styling, so I prefer to use rough, and these are some configuration for styling which usually comes in handy for me. You can choose to leave it or not, right? So let's try and code this up. So starting with imports, I will need an argument parser to make the code look a little nice, and we will be using async.io because it's a couple of modules from there's a couple of modules from Llamaindex that will need using async.io. So there is a reason for using this nest async.io import, and that is also mainly for event loops that comes from our Llamaindex evaluation pipeline. So I'll just tell you later on when it comes in handy, and this warning bit is only to filter out any sort of annoying warnings that we have. I don't know, is it not ignore? I think it is okay, it was filter warnings, right? Okay, and then what do we need? We have pandas. Yes, you need PyTorch, and then you need transformers. You will need so I'm going to use my Hugging Face model, and that is the reason why I'm using transformers. And I'm also going to be using bits and bytes config to load it out in 4 bits. And no need to worry because of these yellow lines. This is only because of my styling that I'd imported. So because of rough, and rough automatically links my code and saying module level code import is not a type at top of file. So this is basically it's unhappy with the ordering of the imports, so nothing to worry. So now let's get into the main Llamaindex import. So there's a couple of things you will need. You will need your settings, you will need your directory loader, you will need a vector store index, and there's also something called a global tokenizer that you'll need. That will come in handy. Llamaindex.core. So you need a couple more imports from your evaluation bit. You will need a embedding QA dataset. You will need a retriever evaluator as well, and another module to generate QA pairs. Few more imports to parse all of your data. I will be using my sentence splitter and index dot so since we are using the Hugging Face embeddings, you will also have to separately import them out, and the same goes for loading the LLMs as well. Okay, I think we have most of the imports, but if there's something, we'll always come back to it. Also, in case this is annoying you, you kind of have to do something. So all you have to do is you can do a rough main.py and you can do a check, and this is all this is saying is, I have a couple of few ones are saying that it's imported but is unused because we haven't used any of them, and few of them are saying it is unsorted or unformatted. So let's not fix them now, but I just wanted to show that that is the reason why it comes up. So first let's define a custom or a system prompt for the LLM, and let's say you are a Q and a assistant. Your goal is to answer questions as accurately as possible given the context, or given the, yeah, I think let's write given the instructions and context provided to you. I think this is okay. I think, yeah, we can always come back and improve on them. There's one more thing that we need. There's something called a query wrapper prompt, and so the model that I was using is Zephyr 7v alpha. So there is a query wrapper that you have to write depending on the tokens that it was used during training, and I think the token is you will first give the user token, you will format in your query string in the middle, and then you will give out an assistant. So what this does is you will just have to define your query wrapper prompt once, and each time you feed in your query, you will not have to format it, just gets auto formatted in this format basically. So your all your questions get formatted in there. So now let us initialize our bits and bytes config. So you will need we will load them in 4 bits because I don't have a great GPU, to be honest. It's an okay GPU. We will use double quant, and the quant type will be n small, nf4, and 4-bit, and the compute type that we'll be using is something called bfloat. So bfloat is a better version of the regular float. It's a little more optimized and takes up only a little bit of space. Yeah, so yeah, we are loading out our Hugging Face LLM. the model is this Zephyr. You can use it from here, or you can, okay. So actually, instead of using this GGUI version, I think you can use the GGUI version. It's better suited with Llama CPP. So instead of that, I will write it out from the original Hugging Face, repository, the GPU version ones. So basically, I think this is the model format, and tokenizer name will also be the same thing. So I guess we can also kind of get rid of this model directory. You don't need it anymore, to be honest, if you're not using it. So this will directly download it from the Hugging Face repository. If you have it, it will just use the cached ones. So you have to pass in your query wrapper prompt. You will have to pass in your system prompt, and there's something called context window, right? And in our case, it is almost 12k, but that's a lot, right? I'll leave it at 3900, but you can always increase it up to, I'm not sure what is the exact one, but I think it is 12k. And maximum new tokens is what is the number of tokens that you want to generate, and you have a keyword passing that you have to give it to your model. And in our case, since we're using the quantized version of it, we will have to pass in our bnb config. And you also have for generation as well, and generation is where you give your temperature and your top k, top p, and all of that. In our case, we will just keep our temperature to a fairly lower amount, and device mapping you can give it to, I have a CUDA device and I have only a single CUDA device, so I'm giving CUDA 0. In case if you have multiple ones, you can leave it to auto, or if you want to use another one, you can go like 1 2 3, anything. Alright, so our LLM is defined. So there's also one more thing we have to do. We have to change our global tokenizer. So what this essentially means is, since we are changing, so by default Llamaindex uses the OpenAI version of the embedding or the embedder. So you have to set the global tokenizer every time you use a custom embedder. So this is one step that you always have to do. And so we have to define our embed model, Hugging Face embedding. So we'll use a fairly small one. I like the one from Pi, so it's BGE small, the English version 1.5. I hope the spellings are correct. If not, we can always come back. So the reason we need settings is because you have to set a global context that I don't want my OpenAI models anymore. I am going to be using a custom LLM and custom embedders. So I think the scaffolding mostly looks okay. So I guess we can get down to writing the argument passes. So parse arguments, and parser equal to, what was it? It was args. Okay, I think it's arg parse, right? And argument parser. Let's give it a nice description here. Let's say tuning RAG parameters. Yeah, it looks okay. And now you will have to keep on adding arguments to this. So our first argument will be, let me see, right, we can give a dataset directory. It will be of type string, and we'll give it a default path as well. So in our case, the default path is just sitting here. So will this work? Oh yeah, so this alone will not work, so let's add a dash in between just to sorry, a slash in between just to be sure. And you can also add a helper flag here saying, you can say directory for the dataset. Yeah, so let's copy it a couple of times now. I think we will 1 2 3 4, I think 5 is enough, but let's see. So the second bit will be for your chunk size, and your chunk size will be of type int. Okay, I think I made a mistake here. I think this should not be enclosed within this thing, quotations. And your default will be 512. Let's use a chunk size of 512, and we can leave the help as just chunk size. The chunk size we have, so maybe I'll just copy this one, since the next one is also a numerical quantity. So I'll be using top k. Top k will be an int, that's fine, and we'll use a default of top k for retrieval. A default of 2 is probably enough, so that's fine. Model name, it will be a string, so our default is basically this. Yeah, and help is model name. Embedder name string, it's the, no, actually embedder is by. So let's use this, and embedder name. Yeah, that looks okay. Yeah, okay, actually there's 2 more things that we need. It might not look relevant right now, but it will come in handy later on. Okay. So I'll tell you what exactly is this PG eval dataset that we need, and there's also one more thing that we need. It's called chunk questions, and it will be of type int, and default I guess we'll leave it at 1. So that's okay. You can change this help bits as well, but I'm a little lazy to do it right now, so I'll just leave it at dash dash dash. You can always change those. So okay, I guess parsing is looking okay. Okay, actually you also have to return your parsers. Yeah, I think it looks complete. So now let's write out our main loop. So I'm using an async function here, and I'll tell you why exactly we need an async function. Equal to underscore main. So we'll be calling our, we have to use async IO to run it, since it is an async function. Yeah, so it looks, for the most part it looks okay, but let's finish this out. So first we will have to read out our what was it? It was dataset underscore directory. We will have to first read out our dataset, and we're using the simple directory reader, and we have to call our load data. And next we have to parse the data that you already have, or chunk it basically. So we'll use a, so chunk size is coming from args dot chunk size. So essentially you're reading out your entire text and chunking them into 512 512 512 512, and you have to create a node data type that Llamaindex uses. Okay, whoop, I should have passed documents, my bad. Yeah, cool. And when you create these nodes, there is an ID that gets attached along with your text as well, and these IDs are quite random. So in case you want to explicitly set them, sorry, node dot id, in case you want to explicitly set them, you know, in descending or ascending order, you can do basically what I'm doing. So essentially what I'm doing is I'm just iterating through each of them and setting them from 0 1 2 3 4 instead of it assigning some random values. So now let's create our vector index with all these, well, all the nodes that we have, and our retriever. I hope this is the correct spelling. Sometimes I can't even, I don't even know these spellings. Yeah, that sucks. Anyway, so as retriever, and we will use a, what was it? Why is it not dot or recommending? I'm not sure. So what was it? I think it was similarity top k, I believe, and we will parse it from our args dot top k. Okay, so we have our retriever as well. So now is the crux of the overall, now comes the crux of the overall program. So in our case, when we are tuning for, you know, values like top k and chunk size, how are we going to tune it? We need an evaluation dataset basically. So that is what this part is doing. So what this module does is, you will pass in your nodes that you have, and we will pass in your LLMs to generate question answer pairs, and for each of these nodes or each of these chunks you can choose how many question pairs that you want. So I think it was chunk questions, right? And the default value was what? I think it was 1. So what this essentially saying is, from each node generate one question answer pair and use my Hugging Face LLM. So that is what this module is doing, and once it is generated, you can save it because it takes a long time to, so this is where it takes a good 30-40 minutes to generate it, depending on how fast your GPU is. So you can choose to save it or not. So if you are choosing to save it, you can reload it back using another module called embedding QA fine-tuned dataset, and you can say from JSON and args dot dataset name. Yeah, okay, so now you have a dataset that is generated, specifically question answer pairs. Now the metrics that we are going to tune our values for, there are two metrics essentially when it comes to a retriever system, that is hit rate and MRR. So I guess going into details of these probably can be another video, so let me know if you want a detailed explanation of what these metrics are. But for now you can just think of them as if two metrics to evaluate our retriever, and they are between the range of 0 to 1. So now this is where we use our retrieval evaluator, and you're saying, oops, so you're saying that the metrics, you're passing in your metrics, and you also have to pass in your retriever, cool, and you will have to pass in your dataset. So await retriever evaluator dot a evaluate dataset. Yeah, so this is the reason we needed to write this as an asynchronous function at the first place, because this module has a function which is an asynchronous evaluation. That's the reason so you have to, anytime you have an asynchronous function, you have to await it, or else it is not going to work. While asynchronous programming is a whole different ball game altogether. So let's not try and go into too much details of that. And once you have your evaluation results, you will have to iterate through them. You will get a list of things, so we will first iterate through them, and It is essentially a list of dictionaries, I believe. So this is how you will pass them. Vals dict, correct? Yeah, vals dict, and we will take each of them and append it to our metrics dict. Yeah, I think this looks okay. So now you have each of your metrics dictionary or metrics individually, taken out. So this is not necessary, to be honest, but I just feel comfortable putting it into a data frame, and there's a reason. So basically I'll just tell you what happens here, right? So once you pass it to your retriever evaluator, you will get evaluation results, but you will get evaluation results for each of the chunk pair that you created. So let's say you had 20 question pairs that you had, so you'll get 20 different hit rate and MRR values. So the reason why I'm converting into a data frame is so I can easily apply my mean on top of it. So I'm a little lazy here, but you can probably write it in a little optimized way. So this is for hit rate, and this is for MRR. Yeah, okay. So we have most of it written down. Now the last part that is left is we will have to track these values. So the first part, what we'll do is we will get our arguments from our function that we defined earlier. Oh right, you also have to pass them, pass your args to your. So did we? We're taking args here, so that's fine. And to use Mlflow, we will first have to set an experiment name. You can give it anything. In my case, I'll just give it rag tuning because that is the experiment name that I previously had. So now you have an experiment name that you've set. So for that experiment name, you can start individual runs. So the runs that I was showing earlier. And now tracking is very simple. You have a function to, you can see what all the things that you can log, right? You have artifacts, dictionary, figure, images, metrics, table text. You have way too many options. You can pick what you want. But in our case, there are going to be only few things that we will be tracking. So one is going to be hit rate, and the other part is going to be the MRR. Okay. So along with metrics, let us also track the parameters that we used. So I saw it somewhere here. So parameters like model name, and then what? We can also track our. So I guess we'll need 1, 2, 3, 4. Yeah, it looks okayish now. Sorry. You can also track your embedders. You will track your top k values. Oops. Okay. Yeah, we'll track our drop k. Then what did we have? We also had a chunk size that we'd had. Chunk size. Yeah, chunk size, and I don't know. Should we also track? I think it's okay to track this thing as well. That is chunk questions. That is how many questions you want generated for each of these chunks. So let's also do that. Cool. So once you're, let's just have a validation that run is completed and logged. Okay. Also, there's one more thing that you can choose to log. That is your dataset. You can version your dataset as well. So you have to do log artifacts, and basically you can log your dataset, this Paul Graham essay, and also you can log out the dataset that we're going to generate. That is this one, the evaluation data set, the question pair chunk. So now what we can do is, now we'll clear out these errors. So you can do that in rough using rough main.py, and you can do a check first. So you have the same problems, and if you want to fix it, you can add the -- fix flag. So you can see that most of these errors have gone away. Okay, so this is still weird. It was able to sort it, and it still has problem with how it was sorted, how it is being sorted. So I'm not sure. Okay, anyways, that shouldn't be a problem. I'll just look into my configuration file later on, but I think code wise most of it looks okay. So running it is fairly simple. You just call it like this: python main.py. So let me just check the flow again. So we will, okay, it's loading these checkpoint shards, so I think it's mostly okay. See, setting my experiment name, and we'll use async IO to call it. Okay, I think we've run into a problem here. So what is the problem? It says string is not callable. Okay, string is not callable. So is it essentially saying that okay, my bad, I've added these bits here, so I guess you should not wrap them in, right? So I guess I forgot that. Okay, so I think let's hope it runs now. So in case you do not have a GPU, you can try Llama CPP. So using Llama CPP, you can run your GGF version model. So that will not need a GPU at all. Or you can obviously go for your OpenAI models. Okay, so you can see a progress bar, right? 0 out of 70. So I think the data set is being created. So it will take a good amount of time, to be honest, 10-15 minutes, whatever. So it takes a very long time. So I will terminate my program here because I've already run it. And once your dataset gets generated, to view the dashboard, what you have to do is you have to type Mlflow UI. So when you type out Mlflow UI, you will see your dashboard getting launched at port 5000, and 5000 is where we have our UI. So you should see your new runs appearing in this table, and you can navigate to chart in case you want to look at your charts, and for individual metrics you can click on each of your individual runs and track all of them. So in case you track artifacts, you will see your artifacts come here, and you also have the ability to download them. So I guess this is it for this tutorial, and I think this was a long one, but hopefully it was a worth it one. And so this is how you can tune your parameters for your RAG. So you can put out different combinations, you can try out different chunk size values, different top k values, evaluate them, log them using Mlflow, and this will probably serve as a decent backbone for you to iterate through your RAG evaluation. So if you have any doubts, feel free to put them in the comments. I'll be addressing all of them. And thank you for watching this video, and I'll see you in the next one. Bye bye.